All right, I assume it's working here. I just don't hear. In fact, it's recording, but I assume the mic is on. So let's go with it. Last section of chapter 5. I believe you guys got your study guide already there. We'll take a look at the study guide on Monday. If there's any questions on it, take a review, do all the homework that we need to be done. And then we take a little test on Wednesday. We good? So let's jam. Okay, 5.5, this is it, last section. How fun is that? It's called the substitution rule. All right, and of course, that's the honesty question. How many of you looked at 5.5 prior to coming to class today? No, okay, straight off the bat, like, we're gonna learn all this right at once. Boom. I don't need to pre-learn anything. Okay. So I'm going to give it to you. So let's go with it here. And so let's do an example first. That'll be easiest here. And example. What we want to do is we want to take the antiderivative of 2x square root of 1 plus x squared dx. That is it. Well, we have a few little problems here. Let's look at the problems first. So let's look at the problems in blue. And so let's see. The problem that I have is I have a multiplication rule between these two. Is that right? So there's a product there just sitting there. Okay, second of all is I have a square root inside here. So I can't multiply 2x directly into the square root. Okay? So I'm kind of like stuck. And the main problem that I have is I have two functions here. In fact, no, actually I have three functions here. I have a square root function on my hands, is that right? I have this little 1 plus x squared function that I got to deal with, and a 2x function. So I got three functions that I'm trying to figure out how to undo, really. And then I have this bright idea. I was like, what? Think back to my good old days in derivatives. Do you guys remember something looked like this? It was like sine, let's say sine of 4x. Sine of x to the 4th. Let's just say it was that right here. Give me the derivative of sine 4x to the 4th. What would be the derivative of that guy? Easily, sine changes into cosine, and the inside stays exactly the same, is that right? Then what do we do? That's right. Derivatives was a long time ago. I totally understand. Plus, it's before 8 o'clock in the morning. What do we do? Something called the chain rule. We multiply by something. I don't know. I think we take the derivative of the outside function, which is now cosine, right? And then we also need to take the derivative of the inside function, which is, anybody? I only get to pick out two people now, so it's going to go back and forth. So Zechariah, the first one to get picked on. Where x to the third. Boom. Okay, so now we see this little relationship. I have an outside function, I have an inside function, and then I have the derivative of the inside function. Everybody see that? Cool. Outside function sitting there. I have an inside function, and then I have its derivative just sitting out there. Whoa, I think this is so cool. So now, guys, talk to me, see if we see it here. Do we see an outside function called the square root? Remember, this is the square root of something that's inside. And the inside stuff is 1 plus x squared. Very good there. So I see an outside function, I see an inside function. And the question is, do I see a derivative of my inside function? Absolutely. So what we're doing here is we're undoing the chain rule. So now we have to go backwards. Good. And that is called the substitution rule. So how do we do that? let's jam. Let's jam and do that. So, what we do is we do something called a substitution. And so now, thinking caps on, let's go with it here. What we're going to do, and usually the letter that we use is U, a U substitution. So we say to ourselves, you know what? I want to make this into one single function. And we're always going to pick the inside function. And sometimes it's a little guess and check to figure out if it works. We're good? But here's my U substitution. And if I take the derivative, I'm going to take the derivative of U. Look what happens here. There, and I'm going to take the derivative of 1 plus x squared. What is 1 plus x squared? Derivative is? I get to pick on Nicholas now. Go ahead. Yep, involves a 2x, and then we're all going to say dx right here. Oh, we see it. Don't you guys see it? 2x over here and 2x over there? So here's what we're going to undo. This is why it's called the substitution rule. We're going to say, look, I'm going to put this in front. I'm going to scoot that little 2x dx all the way to the back. As we undo the chain rule. Okay, and then we're going to substitute now. So 1 plus x squared now has become the square root of u. And what does 2x dx become? Is that correct? No, that's all right. No problem. That's what we hear. That's what's still before 8 o'clock in the morning. Look at this little guy right there and right there. So now what we've done is we've changed our variable, but we've also changed our variable of our differentiation. Are we good? Oh, this is so cool. Hold on. This is much simpler to do now. This is u to the 1/2. So question is, what is the antiderivative of u to the 1/2? Nicholas, I love this. I can bug you guys all day long. No problem. We're going to take the exponent. We're going to add 1 to it. So boom. Plus kind of like 2 over 2, right? 3 over 2. And we're going to divide by that guy, 3 over 2 plus c. Make it a little easier to see. Oh, you know what? I'm going to try this. I'm going to see if I can do this here. Oh, yeah, this is cool. I'm going to move this over. Love it. Okay, so then u to the 3/2. And then what we're going to do, because that's a complex fraction, is so easy. Just take the reciprocal and be a multiplier. 3 divided by 3/2 means multiply by 2/3 plus c. We are not done yet. Because originally, what our variable was x, not u. So what we're going to do is we're going to back substitute everything in. What's u again? Is that right? What's u again? Hey, all right. We're gonna put in 1 plus x squared right into there. So I need some more room. So it's going to be 2. 1 plus x squared. We have over 3 plus c, and I am done. We're good? All right, are we good? So now what I want to do is just check it. Is that true? Do I actually get that? So you guys, since we've done derivatives before, all yours. Can you take the derivative of this guy? Crazy, looks kind of crazy at first. I want to see when we take this derivative, plus c. In fact, you know what? Let me erase it just real quick here. I believe probably the way it was probably written originally would probably like this right here, like this, like that, square root taken to the third power divided by 3 plus c. Okay, can you guys take the derivative of this guy? There you go. Square root 1 plus x squared, third power. All right, now let's see. I think I'm going to still change it back to the 3/2, right? It's easier to take a derivative of power functions, right, than square roots. So I just kind of tricked you a little bit. But what you probably want to do, kind of looks like a complicated derivative, doesn't it? Or we just haven't done derivatives for a while. I would probably do this first, right? Change it back to 3/2. See, I was just messing with you guys here. There. And then now let's see if we can do this here. Think chain rule real quick here. The c value is going to go to 0, right? So we don't care about the c value. So here's what we got. We got ourselves a multiplication of 3/2. Right, because that exponent comes down as a multiplier of 2, 1 plus x squared. And this becomes 1/2 now, right? That's 3. Everybody good there? And the chain rule says multiply by, what do we multiply by? Whatever the derivative of the inside function is that right? Because look at this, we took care of the power function now. Now we're just taking care of the inside function now. And that's going to be 2x. And question is, what's going to cancel? Okay. There it is. Okay, bam. Let's see what's going to cancel. The 3's cancel, the 2's cancel. And I'm left with a 2x multiplying the square root of 1 plus x squared, which is what we started off in the first place. Are we good? So technically, we're just undoing the chain rule. We're good? And this is called, sometimes it's called U substitution, sometimes the substitution rule. Very rarely, though, do you have to do a double substitution. Whoa, you're going to do substitution, and then on top of that, you're going to do another substitution. I don't think we'll get into it today, but it's super fun though. Okay, let's go with exercises here. Exercise, oh no, sorry, definition, or let's give the formula. So properly, let's give the formula of this guy. So you're saying this here. If u is equal to the function of g, which is going to be our inside function, and first things first, it has to be, right, you got to be able to take the derivative of it. So differentiable. So this function has to be differentiable on an interval. Oh, spell that again. Interval I. So here's our function then. So I got then the antiderivative of the f of g of x. So notice that's the outside function and I have an inside function. We good? And then the derivative of the inside function with respect to the x-axis, or with respect to the x variable, sorry. Then the antiderivative could just be f of u du. So that's why it's called U substitution, because we almost always use u as the variable of substitution. Okay, now let's begin. a whole bunch of problems. This will be super fun. And please do, let's see, I would say 5.4 and 5.5. Those are so important sections to go on with these antiderivatives, because 5.4 was kind of like the regular algebra, do some algebra to manipulate the situation so you can take the antiderivative. Okay. This one is, I've done the algebra, I still can't do it. Let me see if I can substitute. Let me see if there's a connection between the inside function and a derivative. Okay, so let's begin. Dun, dun, dun. Exercise 1, please. Find. I'm going to go like this here since we're going to have a whole bunch of them. Changing things around here. Here it is. How about find dot, dot, dot. X cubed. Oh, let me write it the way I want to write it here. Cosine. Okay, some easy ones here coming your way. And give you guys, let's see, 30 seconds each, or 30 seconds each problem. And let's see if you can try to figure it out. Think to see if you have an outside function. Think to see if you have an inside function. And then see if you have a derivative of the inside function. It's super cool. All right, you talked to me here. What did you use for the U substitution? U equals? Awesome. Dun, 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 dun. U equals, I'm gonna make a different color too. U equals x to the 4th plus 2, perfecto. Since Nicholas did that, then Zechariah, you get the derivative. Derivative is dx. Okay, that's cool. Everything is set. Oops, we got ourselves a little problem. Oh, shucks. I see that x cubed. I see that just fine. It's an extra 4 in there. Only we had a 4. Hey, you know what? 4 is a constant, isn't it? How about this? I'm going to multiply this whole thing by 1 in front. Does 1 change anything as a multiplier? Nah, except I'm going to trick the system. Ready? I'm going to make that 1 into a 4/4. That's still 1, isn't it? Love tricking the system. Okay, so now let's kind of get things into, oh, let's see. So I multiply by what I want as a constant, and that only works for constants. You can't say like, I'm going to multiply x over x and scoot things in. It doesn't work that way because that's a variable. But yes, 4/4, 12/12, -7 over -7, sure, absolutely. Okay, so now I'm going to start setting things up. So I want the top 4, I want the numerator to come over. Don't want the denominator to come over. So this then becomes 1/4 on the outside. Let's move things around. I'm going to have cosine here. That's of x to the 4th plus 2. And that 4 slid all the way to the end. Now I have it as a multiplier. And if you want to put a little dot, kind of just to separate everything, that's what I kind of do. So 4 came in with the x cubed, which now sits with the dx in the back. Oh, now can I substitute? All right, all yours here. Can you substitute the u and the du where they need to go? And that's pretty easy because you know exactly what u is. You just substitute that in. You know what du is because you set it up already. Just bring it in as a all right, and I'm going with it here. Whoopsie. This is not cool. Got this. So I think the substitution is 1/4 antiderivative cosine of u du. Everybody agreed there. Sweet. Equal sign, I guess. All right, now what I need is I need the antiderivative of cosine. Nicholas, we'll pick on you again. This sign is perfect. Okay, so I got myself my 4th in front, and it becomes sine of u. Well, see, there's nothing else there, right? Because we're just taking the antiderivative of cosine. And dun dun. Now we're going to back substitute our u value. Back substitution was, I forgot already here. X to the 4th plus 2, I think it was, right? Yep. X to the 4th plus 2 plus c. Okay, are we good there? Is that correct? You were done already? Yeah. Awesome. Okay. Do we need to try the derivative of this guy? Are you guys okay? Let's try the derivative. Let's see. Notice that little extra 1/4 that we made, right? Or that we created. That's going to be to undo the x to the 4th derivative, right? Because remember the exponent is going to come down. But we didn't have a 4 in the beginning of it all, right? So that little extra 1/4 now takes care of it so that we get exactly what we want out of it. Okay, so what we need to take a derivative of is 1/4 sine of x to the 4th plus 2 plus c, and derivative of c will be 0 anyways. Okay, so derivative of that would be, let's see, 1/4 is going to stay on the outside, right? Just chilling. The derivative of, so 1/4 on the outside. Derivative of sine is cosine. And the inside stays the same. Multiplied by the derivative of the cosine. Oh, sorry, no, multiply the derivative of the inside function. And then plus c would just be plus 0. Okay, and there it is. That 4 and that 1/4 will cancel themselves out. And final answer looks like this. Oh, no, not final answer. We don't like the multiplier to be in the back. So what we normally do, we put it in the front. And that's exactly why it was in the front already as opposed to in the back. Because any multipliers we like to stick in the front. So x cubed was there, sitting. Bam, U substitution. We're good? Okay, let's practice. Time we got? I think we're good. Okay. This is B now, I believe. You know what? Let's do this here. Let's do the first one that we did today. Except I'm not going to give you the 2. So can you guys do this one? So look at the first one that we just did. Give you guys 30 seconds. Okay, 42 seconds. Okay, a minute and 42 seconds. So things that we learned from A, look at the work for our example and see if you can put that together here. All right, go for it. Wow, and someone's streaming. That's good. Okay, I want to see how you guys did. Raise your hand if you think you are done and finished and everything's cool like that. Okay, so let's jam. Okay, so our example, we had a 2 inside there with the x, right? So we're looking at this here, thinking to myself, you know what? That looks like the inside function to me right there. And then I'm kind of like, in my mind, I kind of quickly do the derivative of it. So 1 plus x squared, the derivative of this guy would be 2x. Okay, that's cool because I have the x over there. Now what I'm thinking of doing is multiplying by 1 because I need that little 2x. So only thing I'm going to change here is I'm going to say, you know what? This is going to be a 2 over 2 as a multiplier in front. That way, I'm going to get my 2x at the end. So it's a little bit of planning on our part to make sure we get what we want out of it. That's what I want. Now I'm going to go with the U substitution. So U is equal to 1 plus x squared. As I planned it out already here, du is 2x dx. And my little multiplier in there. That's cool. I can do that now. So 1/2 stays on the outside. Antiderivative of the square root of 1 plus x squared. I put a little dot right there. I like to separate that with a dot because it kind of makes me see exactly what my dx is. The 2 just slid on top with the x over to the dx. And lovely. I got that. I have the square root of u now, du, and that is an easy one. Now, notice when I do that, I'm back to 5.4. That's exactly what I want to get to. I want to get to a function I can take the antiderivative of, done. All right, a little bit of work here. So 1/2 antiderivative of u to the 1/2 du. And we keep on going. Is red okay to see? You guys see red over there? Okay. Okay, we're going to add 1 to the exponent, is that right? Divide by the reciprocal. So let's see if we can do this in one step this time, because we're cool like that. So 1/2 is a multiplier on the outside. U comes in now as 3/2. All right, because we're adding 1 to the 1/2. So instead of putting 3 over 2 on the bottom, which is dividing by the new exponent, all we're going to do is we're going to take the reciprocal immediately. Are we good? Boom, boom. Same difference, just one step less. All right, we have to put a little plus c in there. And we can do this all in one step. I usually like to simplify first before I plug stuff in. So that 2 and that 2 cancels off. It's got u to the 3/2 over 3. Now it's just over 3. That's cool. And then back substitute what we have, 1 plus x squared. 3/2 over 3. So that is just perfect. And another way of seeing it, that's another way of seeing it right there. Okay, boom. Can I throw some more difficult ones at you now? 1, okay. Okay, so let's, where are we on C? Okay, you guys, this one now. Antiderivative of x, then I have a square root of 1 minus 4x squared dx. Okay, we're gonna go kind of fast just because of time. Very good. So let's jam. So thinking to myself, and if you could do it ahead of me, go for it. So I do see a big inside function, big outside function, right? I see the little skirt on the bottom. That skirt is huge. So inside function is 1 minus 4x squared. And then sometimes you guess at the U substitution, you see if it works. And if it doesn't, you just try something else. So good. So that's cool. That's cool. So I'm going to do, because that little square root in there, just sitting there, I am pretty sure that my U will be 1 minus 4x squared. You just have the sneaky idea. So that means du would have to be a negative 8. Right? Because we're going to multiply the 2 times the negative 4. Negative 8x dx. Tell me if you guys agree. Sweet. Oh, nice. What do we do with the negative 8 now? Well, guess what I see? I see an x on top. Notice they have the x on top. Can I slide that x all over to the dx as a multiplier? Yeah, I can do it on the front. I can do it on the side. I'm just missing a negative 8. So here's what we do. Negative 8 over negative 8 is good by me, right? Because that's technically a 1. I need both of them to be negatives. Because I need to be multiplied by a positive 1 instead of negative 1. So there's my multiplier. Okay, so 1 over a negative 8, or I could just put negative 1/8. We good? The negative comes from the bottom. All right, now I have a 1 over the square root of 1 minus 4x squared, multiplier by a negative 8x dx. And I got myself my substitution step now. So negative 1/8, antiderivative of 1 over the square root of u du. Awesome. That looks simple now. And because of that, I can get rid of fractions. I don't like fractions. See, u, the square root of u is really u to the 1/2. Everybody good there? If I move it to the top, it's going to be u to the negative 1/2 du. Okay, are we good there? Okay. Let's see who did I pick on last, Nicholas. So Zechariah, tell me what should we do here? How do we undo u to the negative 1/2? Cool, okay. So my negative 1/8 is still here on the outside. I'm going to add 1 to the exponent, which makes it a positive 1/2. Is that right? So you guys okay with the positive 1/2 because I added 1? And again, it's a fraction. So instead of putting it as divided by 1/2, I'm going to say multiply by 2 over 1 plus c. Let's do our reductions here. So that's 2 becomes a 1. That guy just becomes a 4. And then we're going to back substitute the u. So don't forget 1 minus 4x to the second. And do a square root there. I'm running out of room. You guys have to help me out. Make sure we get it correctly here. Okay. Are we good there? Let's go back substitute everything in that we need. So negative, I got negative 1/4 multiplying now. The 2's canceled, right? And there's a 1 on the bottom, so that goes away. So this is just going to be multiplied by 1 minus 4x squared plus c. And to make it look a little nicer, how about a negative on top? Square root of 1 minus 4x squared over 4 plus c. Okay, good there. We're jamming. Let's keep on jamming. We got D, and we got a few minutes left here, so I want to get to the difficult one and the fun one. Okay, you guys all yours for this one. All right, anybody see an outside function? Thinking E is the outside function, right? Anybody see an inside function? E is the function, right? But the stuff inside the exponent, yeah, absolutely. So let's go with it here. I'm thinking this one right here. I'm thinking, let me change to blue. U is equal to 5x. Give me du. Anybody? Not all at once. I'm thinking just 5, is that right? 5 dx? Okay, can you guys do all your magic? Do all your magic work to get you to the antiderivative. Go for it. This one I am going to give you about 35 seconds. All right, so I'm thinking that 5 is missing, right? We need a multiplier of 5. How do we make a multiplier of 5? What should we multiply initially in front? I don't know. So Nicholas, I think Nicholas is the next on the list for torture. What should we multiply in front? Technically, we're multiplying by 1, right? But we need a 5 at the end. It's all yours. Not sure. Okay, no problem, no problem. So technically we want a multiplier of 1 because 1 doesn't change anything, but we need this guy. So how about that's all we need on the outside. Multiplier of 5 over 5. We're gonna set this guy up. What a setup. This would be so fun. So now we got ourselves a 1/5 e to the 5x, and we just drop that or slide that 5 all the way over next to the dx. And now I got myself my substitution. 1/5 on the outside, everything's good. I'm gonna go e to the u du. Boom, love that. Let me change that du just a little better. All right, du. Zechariah, antiderivative e to the u. E to the u, absolutely. So we got 1/5 here, multiplied by e to the u plus c. And all we got to do is back substitute the u back in. So I'm going to write it over here. So I was supposed to go into the next slide here. I'm going to go with, it's going to be over 5 e to the 5x plus c. And if you take the derivative, that in your mind, you should end up with 5 e to the 5x. Okay, the toughie with a few minutes left here. Can I go fast? I'm gonna kind of go fast real quick here, okay? So DE, let's go quickly here. Back to the one that we started off with. Love this guy. Ding, 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 ding. Okay, thinking caps on just for a little bit here. Let's go. We've done this already. Oh, sorry, guys, real quick here. Sorry, one more little thing to add. I forgot to see it. X to the 5th. Let's throw in a weird X to the 5th into here. Running really out of time here, so we're gonna go with it here. So what is the substitution step we have used so far? We have the X to the 5. How do you get rid of X to the 5? That's gonna be crazy. But let's go with it. Let's see what happens here. This is why substitution, U substitution gets a little crazy sometimes. Everybody okay with that substitution step right there? Sweet. Okay, so the du, just so we know, eventually what we want as a derivative is 2 dx 2x dx. Okay, that's cool. Okay, we're gonna jam here because with algebra students coming in. Okay, if that's the case, I need a 2 in here, right? So this is 2 over 2. Everybody agreed with that? That's coming in. But before we multiply that in, I got to get rid of this x to the 5. So here's what we do. I'm going to do this. See that u is equal to 1 plus x squared? I'm going to make this into a u minus 1 is equal to x squared. Is that true? Can I just move the 1 over? Yeah. So I'm actually going to substitute for the x. So let's see what I need. This is the toughie. You guys ready? I need this 5 to be broken up into a x to the 4 times x. The reason why I need this x is because this x is down here. Good there? So I really just need to substitute x to the 4th. Oh, guys, check this out. If I were to square this guy and square this guy, will I get x to the 4th? So now this guy becomes u squared minus 2u plus 1. Everybody agreed with that statement. I just kind of foiled that out real quick here in my brain. Everybody good there? Okay, let's jam. Let's finish up this here. Let's see. I'm going to stick just so we don't get too confused. The 2 and the 2 goes on the outside still stays there. This guy becomes the square root of u. Good there so far? The x to the 5th becomes u squared minus 2u plus 1. And then this x is a leftover because I want that 2 in there. So now let's see, 1/2 substitution of u squared minus 2u plus 1, 2x dx. Now I can substitute that. Now I can substitute my variable in. Usually we do it all at once, right? But I want to show you the little parts. Let's get to the end here. Okay, and then what we're going to do is we're going to distribute this guy into here each time. So think of this as a u to the 1/2, right? It's going to multiply that. And when you multiply that, we add exponents. Is that right? Multiplication of numbers meaning add exponents. And this right here becomes du now. Okay, I'm going to let you guys finish. What I do want you guys to do is read through. We just started this. This is example 5 right here that we just started. And then I want you guys to read through example 6. Now, example 6 is cool because we finally get to figure out this. We figure out what is the antiderivative of tangent, which we have no clue yet. We're going to actually make the antiderivative of tangent. This is example 6. And don't forget, for the homework, if I put a number here and I put a number here, it becomes a definite integral, right? So read through example 7, no, not example 7. Yeah, example 7 for the definite integrals. So go with it, okay? All right, and then you have your homework here. We'll come back on Monday to look at homework from 5.5.